What if the greatest obstacle to exploring the universe is not technology, but the laws of physics themselves? Not money, not better rockets, but rules that cannot be broken no matter how advanced we become. Imagine building the most powerful spaceship ever created, only to realize the universe has already set limits you cannot cross. And today, we're going to understand exactly why, where we take the most complex ideas in physics and make them simple, clear, and fascinating. In this video, we explore a deep question. Why is space travel so incredibly difficult? And more importantly, why might the laws of physics themselves be holding us back? Let's start with a simple idea: conservation of momentum. It sounds complicated, but it's actually very simple. If you push something in one direction, something else must move in the opposite direction. This is not a suggestion. It's a rule of the universe. Now think about walking. When you walk forward, you push the ground backward. The ground pushes you forward. Simple. But in space, there is no ground, no air, no surface, nothing to push against. So how do rockets move? They throw mass out the back. Hot gas explodes out of the engine, and the rocket moves forward. This works perfectly, but it creates a huge problem. Every bit of movement requires throwing something away. Now let's take this further. If you want to go faster, you need to throw more mass backward. That means more fuel. But here's where things get serious. The more fuel you carry, the heavier your rocket becomes. And a heavier rocket needs even more fuel to move. This leads us to something called the rocket equation. And it tells us something shocking. To increase your speed, you don't just need more fuel. You need exponentially more fuel. Not double, not triple. Much more than that. So if you want to go twice as fast, you might need 10 times the fuel or more. Now imagine trying to reach another star. You would need a rocket so massive that most of it is just fuel, carrying more fuel, to carry even more fuel. It becomes a losing game. Now let's talk about energy. Another unbreakable rule: conservation of energy. Energy cannot be created from nothing. Every bit of speed costs energy. And the faster you go, the more energy you need. But here's the surprising part. Energy increases very quickly with speed. To reach even a small fraction of the speed of light requires enormous energy. We're not talking about a big power plant. We're talking about energy on the scale of entire countries. Now think about this. You don't just need energy to speed up. You also need energy to slow down. So a round trip in space requires double the energy. Going fast is hard. Stopping is just as hard. Now we reach the ultimate barrier: the speed of light. This is not just a fast speed. It is the maximum speed possible in the universe. Nothing with mass can reach it. As you get closer to this speed, strange things begin to happen. Time slows down. Mass increases. And the energy required starts to approach infinity. That means, no matter how advanced your technology is, you can never actually reach the speed of light. It is a hard limit, built into reality itself. This is where the genius of Richard Feynman comes in. He had a simple way of looking at things. The universe follows rules. It doesn't care about our goals, our dreams, or our ambitions. It just follows laws. And these laws are consistent everywhere. Feynman didn't see this as a problem. He saw it as truth. Space travel is not impossible, but it comes with a cost defined by physics. Every step forward must be paid for. So are we completely stuck? Not exactly. Scientists are working on new ideas. Ion engines, which use very little fuel but are slow. Solar sails, which use light itself for movement, nuclear propulsion, which offers more energy, and even theoretical ideas, like warp drives. But here's the reality. Almost all of these ideas still follow the same fundamental laws. They don't break the rules. They try to work within them. So what have we learned? The challenge of space travel is not just engineering. It is physics. The universe has built-in limits. Momentum must be conserved. Energy must be accounted for. And the speed of light cannot be surpassed. These are not obstacles we can remove. They are rules we must understand. And maybe that's what makes space exploration so fascinating. Not because it's easy, but because it forces us to face the limits of reality. If you enjoyed this journey into physics, subscribe to Feynman Simplified and explore the universe one idea at a time.